Hi, welcome back. This is Mark, and today we're going to discuss computer memory system. A memory, as you can see on the screen right now, is just like a human brain. It is used to store data and instruction, and the computer memory is the storage space in the computer where data is to be processed and instructions required for processing are stored. The memory is divided into large number of small parts, which you can see here. Examples of those small parts are this individual integrated circuits that are attached to the board. And each location or each part is actually called a cell. Each location or cell has a unique address which varies from 0 to memory size -1. For example, if computer has 64K words, then this memory unit has 64 times 1024, which is equals to 65,536 memory location. The address of these locations varies from 0 to 65,535, which is -1 from the 65,536. Why? Because we started with 0. The memory is primarily of two types, and it's what you can see on your screen, which is the internal memory and the external memory. An example of the internal memory is the cache memory and the primary or the main memory. Example we have here is the RAM or the random access memory. The other type is the external memory, or an example for that would be the magnetic disk or a hard disk or the optical disk. Next is what we call as the memory hierarchy. This is a diagram showing the characteristics of a memory hierarchy. And as you can see here, we have the CPU registers, cache memory, and main memory, which fall under the internal memory. Okay, and then for the external memory is the magnetic disk, optical disk, and the magnetic tape. And you can see also here on the side, there's an arrow pointing upward, which signifies that speed increases as we move up the memory hierarchy. Aside from that, the characteristics of this diagram is that as we go from top to bottom, okay, remember from top to bottom, going down, the capacity in terms of storage increases. Next is the cost per bit of storage decreases. Okay, so if it's cost, when it goes down, storage cost per bit of storage decreases. And then frequency of access of the memory by the CPU decreases as well, while the access time by the CPU increases. Remember, in that memory hierarchy, when it's going down from top to bottom. Now the RAM, or the random access memory, constitutes the internal memory of the CPU for storing data, program, and program result. It is read-write memory, and that's what we call the random access memory. Since access time in RAM is independent of the address, the word that is each storage location inside the memory is as easy to reach as other location and takes the same amount of time. We can reach into the memory at random and extremely fast, but can also be quite expensive. So the RAM is volatile. Example, data stored in it is lost when we switch off the computer or if there is power failure. Hence, a backup uninterruptible power system or UPS is often used with computers. Now the RAM is small, both in terms of its physical size and in the amount of data it can hold. Now there are also two types of RAM, and these are static RAM and the dynamic RAM. Now the example that you can see here is a static RAM or SRAM. The word static indicates that the memory retains its contents as long as power remains applied. However, data is lost when the power gets down due to volatile nature. Now, SRAM chips, as what you can see here, is used or uses a matrix of 6 transistors and no capacitors. The transistors do not require power to prevent leakage, so SRAM need not have to be refreshed on a regular basis. Because of the extra space in the matrix, SRAM uses more chips than DRAM for the same amount of storage space, thus making the manufacturing costs higher. And static RAM is used as cache memory, which needs to be very fast and small. This figure that you see is the dynamic RAM or DRAM. Now, unlike SRAM, must be continually refreshed in order for it to maintain the data. This is done by placing the memory on a refresh circuit that rewrites data several hundred times per second. DRAM is used for most system memory because it is cheap and small. All DRAMs are made up of memory cells. These cells are composed of one capacitor and one transistor. Read-only memory or ROMs, the memory from which we can only read but cannot write on it. This type of memory is non-volatile. The information is stored permanently in such memories during manufacture. And a ROM stores such instructions as are required to start computer when electricity is first turned on. And this operation is referred to as bootstrap. The ROM chip are not only used in the computer but also in other electronic items like washing machines and microwave oven. There are various types of ROM and these are the following. The first one is EEPROM or mass PROM. Next is programmable read-only memory. Next is erasable and programmable read-only memory. And finally, electrically erasable and programmable read-only memory. The one that you can see on your screen is an example of EEPROM or mass PROM. The very first ROMs were hardwired devices that contained a pre-programmed set of data or instructions. These kind of ROMs are known as mass PROMs. It is inexpensive ROM. That means these ROMs are cheap. Next is the PROM or programmable read-only memory, which can be modified only once by a user. The user buys a blank PROM and enters the desired contents using a PROM programmer. Inside the PROM chip, There are small fuses which are burnt open during programming. It can be programmed only once and is not erasable. Next is the EEPROM, or Erasable and Programmable Read-Only Memory. The EEPROM can be erased by exposing it to ultraviolet light for a duration of up to 40 minutes. Usually, an EEPROM eraser achieves this function. During programming, an electrical charge is trapped in an insulated gate region. The charge is retained for more than 10 years because the charge has no leakage path. For erasing this charge, violet light is passed through a quartz crystal window. This exposure to ultraviolet light dissipates the charge. During normal use, the quartz lid is sealed with a sticker. And lastly, the EEPROM, the or electrically erasable and programmable read-only memory, is programmed and erased electrically. It can be erased and reprogrammed about 10,000 times. Both erasing and programming can take about 4 to 10 milliseconds. In EEPROM, any location can be selectively erased and programmed. EEPROMs can be erased one byte at a time rather than erasing the entire chip. Hence, the process of reprogramming is flexible but slow. Now on the screen, it is presented the two types of access devices, or in other words, the memory access, which is serial versus direct access memory. So the first example that we have here is the serial access device or serial access memory, and the other one is a group refers to the direct access memory devices. In the serial access memory, or the sequential access, means the system must search the storage device from the beginning of the memory address until it finds the required piece of data. Memory device which supports such access is called a sequential access memory or serial access memory. Magnetic tape is an example of the serial access memory. The other word is the direct access memory or random access memory, which refers to conditions in which a system can go directly to the information that the user wants. Memory device which supports such access is called a direct access memory. Magnetic disks, optical disks are examples of direct access memory, including are the USBs or universal serial, the flash drives that we have also is an example of a direct access memory. Cache memory is a very high-speed semiconductor memory which can speed up your CPU. It acts as a buffer between the CPU and the main memory. It is used to hold those parts of data and program which are most frequently used by the CPU. The parts of data and programs are transferred from disk to cache memory by operating system from where CPU can access them. There are advantages and disadvantages to cache memory. Under advantages, cache memory is faster than the main memory. It consumes less access time as compared to main memory. It stores the program that can be executed within a short period of time, and it stores data for temporary use. For the disadvantages, cache memory has limited capacity. And lastly is that the material used for cache is very expensive. Next is virtual memory. So what is virtual memory? Virtual memory is a technique that allows the execution of processes which are not completely available in the memory. So the main visible advantage of this scheme is that programs can be larger than physical memory. Virtual memory is the separation of user logical memory from the physical memory. Now, with this separation, it allows an extremely large virtual memory to be provided for programmers when only a smaller physical memory is available. Now, to follow are the situations when the entire program is not required to be loaded fully in the main memory. The situations are, the first one, user written error handling routines are used only when an error occurred in the data or computation. Next one, certain options and features of a program may be used rarely. Many tables are assigned a fixed amount of address space, even though only a small amount of table actually used. The ability to execute a program that is only partially in memory would counter many benefits. Less number of I/O would be needed to load or swap each user program into memory. A program would no longer be constrained by the amount of physical memory that is available. And finally, each user program could take less physical memory. More programs could be run the same time with a corresponding increase in CPU utilization and throughput. The next is the auxiliary memory, or in other words, these are also called as secondary memory. Now, the auxiliary memory is much larger in size than the main memory, but is slower. It normally stores system programs, instruction, and data files. It is also known as secondary memory, and it can also be used as an overflow virtual memory in case the main memory capacity has been exceeded. Secondary memories cannot be accessed directly by the processor. First, the data information of auxiliary memory is transferred to the main memory, and then that information can be accessed by the CPU. And the characteristics of auxiliary memory are the following. The first one is non-volatile memory. Data is not lost when power is cut off. Next is reusable. The data stays in the secondary storage on permanent basis until it is not overwritten or deleted by the user. Third is reliable. Data in the secondary storage is safe because of high physical stability of secondary storage device. Next is convenience. With the help of a computer software, authorized people can locate and access the data quickly. Next is capacity. Secondary storage can store large volumes of data in sets of multiple disks. And finally is cost. It is much less expensive to store data on a tape or disk than the primary memory. So this ends our discussion on computer memory system. Thank you for watching. Have a nice day. Bye.